Hello, everybody. Welcome to the last lecture of this first unit, this first chapter, where I'm going to depart a little bit from the textbook and look at the limits of science. Because, as you may have noticed, the textbook doesn't clearly define the limits of science. And to be honest, no science textbook I've ever read does, which should be concerning to you, right? Because everything has limits and boundaries. And by not spelling out what the limits are and boundaries are, the author of the textbook and of many other textbooks I've read kind of betrays a pseudo-religious devotion to the scientific method that implies maybe there are no limits, which of course is nonsense, as we'll go through here. So again, scientific skepticism. Skepticism is good. We like asking questions. And I'm going to go through some of the inherent limits of science, and maybe we can have a great conversation about why you agree or disagree with me. But again, it's interesting that the book didn't point these out, and that most science textbooks I've read, I can't think of a single one that actually specifies the limitations of science. And that should be concerning to any intelligent person who's reading a science textbook. So, what are the limitations of science? It's a question. It's a great question. And it's one I want you to think actually really thoughtfully about, because it's an important question. And it will change whether or not you are scientifically literate or you're scientifically indoctrinated, right? Because you can have a pseudo-religious devotion to something that isn't religious at all, because you're indoctrinated into a way of thinking. Or you can be literate and understand it, but also know its limitations. And if you don't know its limitations, you're probably indoctrinated. And that's not a good thing. So, the limitations of science. So, for over 100 years, there has been something called methodological naturalism, where the explanations that are allowed, and the only explanations that are allowed, are matter, energy, and the laws of physics, right? So you can only explain the occurrence of something that has happened through matter, energy, and the laws of physics. All other explanations are not allowed. It's called methodological naturalism, and it's been the reality of science as long as I've been alive, and I think for at least the last 100 years and probably more. Any explanation that involved any kind of intelligence or God is called the God of the gaps. Oh, you're just saying it's too complicated, it's a God of the gaps, right? This is the sort of intellectual attitude that is pervasive in the scientific endeavor. It has no bearing on whether or not God actually exists, or gods actually exist, or extra-dimensional beings of high intelligence actually exist. They're just not allowed explanations. It's a limitation on science. And to be clear, I actually think it's a great limitation that should be on science, right? Science should attempt to explain material occurrences with material causes as much as humanly possible. But you should also understand that science only explains material occurrences with material causes, and that is an intellectual limitation placed upon the endeavor of science. So when people say science has explained away God, I chuckle very happily. I laugh because it's an absurd statement, because God is not inherently a physical entity like we think of a physical entity within our universe. He would definitionally be outside of our universe and not part of creation. And so saying that someone has disproven the existence of God using what is created, our universe, which God is essentially not a part of, like fundamentally, is amusing to me. It's a really funny statement to say that science has disproved God. It's absolutely intellectually vapid. It misses with any kind of strength. It doesn't hit at all. There are some great arguments to be made against the existence of God, but science doesn't have any of them. They're all philosophical in nature. Science is inherently not looking for God. In fact, if you find anything that hints at God from modern science, it's quite by accident. It's not on purpose. So things like fine tuning and some other things that we'll talk about later this year that do kind of hint at an intelligent cause are a accidental consequence of good science, not a goal, right? In fact, the reality that scientists have come up with a conditionally plausible explanation for the universe coming into existence from nothing, life self organizing and then evolving, that's not compelling. It's not really interesting. It was actually inevitable because the rules of the game that we gave to the smartest people on the planet were matter, energy, and the laws of physics. And those were the rules that we gave them to play by. And so, of course, they're going to have an explanation that involves nothing but matter, energy, and the laws of physics. If that's the rules of the game, you should expect the answer to fall within the rules of the game. So, when I say limitations of science, there's a hard limit there. It's not that the explanation is correct, it's that the smartest people on the planet had nothing to do but make that as their goal. They're trying to explain everything with matter, energy, and the laws of physics. And that's science. That's what science is. And again, I don't think science should go beyond that. I think that is a great limitation for science to have. But if you understand what science is, you understand that limitation. And so you understand that, as Stephen Jay Gould said, science and religion occupy non-overlapping magisteria. One can kind of inform the other in some interesting ways, but for the most part, they don't touch each other. They're in totally different domains of knowledge, understanding, and pursuit. So yeah, that's, I would say, the first limitation of science is an intellectual limitation that is valid, it should stay, and it shouldn't change. But you as an individual who could be suckered into an ideology that says that science has no limits and can explain everything could be duped into thinking that that's the truth, when an inherent limitation for over 100 years, or at least as long as I've been alive, over 40 years, is that matter, energy, and the laws of physics are the only allowed explanations. Okay, and so that they've had such a hard time filling in the details of their explanations for all of reality is more telling than that they have explanations for all of reality. But I digress, we'll move on. So this is like attempting to explain the first car without Henry Ford. Okay, that's what science is. Okay, and this is how a religious person could frame this discussion, and that's actually how I, as a religious person, frame this discussion. I love the study of science. I love the study of the car. Okay, but the study of the car says nothing about the person who created the car, right? And so that to me is the line. This is science. This is science and religion. That would be the difference, right? Now, there are some physical limitations to science as well. So we can't see backwards in time past time equals zero, right? What do I mean by that? I mean the Big Bang. The Big Bang, the point at which the universe popped into existence out of essentially nothing, as far as we can tell, which, if you take quantum mechanics as a viable option, if you crush everything into a space that is essentially nothing, then things on the quantum scale pop in and out of existence. You could have the entire universe pop into existence. I think that's nonsensical, but it's very scientific. So that's a possibility. But the point at which everything popped into existence, the Big Bang, is time equals zero. What happened before that? We have no idea. We have no way of knowing. There are 6 to 8 competing hypotheses in the scientific community that I've read. There's probably more. But the possibility, without some major advancements in physics and our ability to detect things that would indicate one answer over another, the answer is probably never going to. We won't have an answer to what happened before time equals zero in my lifetime. Probably not in yours. Probably not ever, because the information that we need to infer what may have happened has probably already expired to time, right? So We can't see past what's time at time equals zero. And that's an interesting limitation because there was a single beginning to reality. Why do I say that's interesting? Because unlike what Richard Dawkins has been quoted as saying, that religious people had a 50-50 chance of getting it right, if some of the hypotheses about the multiverse or the landscape theory are to be believed, there could have been many, many creative events, not just one. Why is there a single time equals zero? We could, in fact, have another Big Bang event occurring right now as we speak, but the light of it has not reached us yet, right? Or multiples happening right now, but the light hasn't reached us yet. So the fact that there is a single Big Bang event pointing to a beginning is an interesting limitation because we don't know what happened before then, only that a single beginning happened. And that's really interesting. Now, you also can't see out past the point at which the expansion of the universe, that's how fast things are moving away from one another, is faster than the speed of light. Now, what's out there? Certainly a lot of more of the same, but we don't know, is the actual answer. Is matter as evenly distributed as it is in this part of the universe? Does it curve off in space-time and back into a bubble? Is there a infinite continuity where the things like the inflationary period were a localized event? The Big Bang was a small localized event in a much larger universe. We have no way of knowing because the light from those places will never reach us because the universe is expanding too fast. So we just don't know. Okay, and then finally, there's something called the Planck scale at the very, very smallest level of reality, and we don't have the resolving power to see below this scale. This is a theoretical visual limit proposed by Max Planck on what we will be able to see in terms of smashing particles to pieces and seeing smaller and smaller bits. And what's down there? Well, we don't know. It could be something that changes our understanding of reality entirely. Maybe there's some kind of base code or program bits like there are for DNA, way down below where we can see. We don't know, and we have no way of knowing. What's down there could change our understanding completely, but we just don't know. So those are three physical limitations of science. We can't see past time equals zero, we can't see past the expansion of the universe, and we can't see down past the Planck scale. Now, another obvious limitation of science that should be noted is we are limited to our five senses and the sensors that we can create to sense things. Why do I bring this up? Well, because during my lifetime, something called dark matter and dark energy have come to prominence, where we see the effects of these things, like on the expansion of the universe, how fast it is pushing apart, and the motion of galaxies being affected by matter that doesn't seem to be there. And we don't have a sensor to sense dark energy, and we don't have a sensor to sense dark matter. So what the heck are these things? We have absolutely no idea. And that, again, it points out a inherent limitation that we are only able to use our five senses and the instruments we can invent to explore reality. We have no way of knowing what other phenomena exist that we can't sense, or we don't have a tool to sense. And clearly, because of dark matter and dark energy, I can postulate there are things that we do not know anything about that exist. What are they? We don't know. And we don't have the tools to know. That's a limitation of science. Now, up until very recently, we've been limited in science by our intellect, right? It's only those things that our minds can come up with, those explanations that we can come up with to test and observe and analyze with, we're limited to our minds. And now that's been expanded to some degree through artificial intelligence. And there's a lot of scientists who think that that'll be expanded to a really heavy degree. And so that'll really expand this particular limitation, the cognitive limitation of science. Because at the end of the day, up until now, until just 5 minutes ago, all science was done by humans, right? And humans are limited creatures. And astute people always knew this, right? They look at people who are scientists and be like, I bet he puts his pants on one leg at a time, you know? He might actually be a human being. Meaning that just because they think something's right doesn't mean they're right. They're humans just like the rest of us. And having a special piece of paper, a PhD, which you spend a lot of time, money, and effort getting, doesn't actually make you more intelligent. It just means that you spent a lot of money, time, and energy accomplishing a specific task. It doesn't necessarily mean you're more intelligent. Now, don't get me wrong, there are some scientists who are actually tremendously intelligent, and I don't mean to insult their intelligence, but you also have to be intelligent and be motivated to go down that path to get that paper. There are a lot of people who are very intelligent who are not motivated to go down that path and get that piece of paper, right? So they are not the only intelligent people, is what I'm trying to say. So caution against intellectual hubris is all I'm going at. Now, because there are people who are not scientists who are also intelligent, they are able to look at the scientists and say, you know, I don't think I agree with you because they can think critically. Well, now with AI expanding that intelligence, the ability to think critically might be reserved to the elite. Maybe only people who have certain types of quantum computers will have access to the most intelligent types of computational algorithms. Well, that'll be really interesting. What kind of gatekeeping will happen there? What kind of skullduggery will be involved? I digress. I'm getting a bit off course here because these are limitations. This limitation is inherent and is not going to change anytime soon. The AI limitation, I think it also has some inherent limitations, but I've actually been wrong about AI in the last 10 years and some of the predictions that I've made. So perhaps I'll be surprised and that horrific singularity where AI becomes more intelligent than us will actually happen someday. Now, this concept that science does not know what it doesn't know sounds obvious, but it really struck me in my 20s when they came out with the discovery of dark matter and dark energy. It became a really known, accepted phenomena. And 80+% of the universe seems to be composed of dark matter and dark energy. And so literally 80% of the universe is made of stuff we know nothing about. Think about that. And so I began to think seriously about the notion that science doesn't know what it doesn't know. And how seriously I took science was based on a false notion that science knew a lot. But I don't know that science knows a lot. It knows more than we used to. It's very useful. It makes some great predictions. But how much of what is to be known does science actually know? If it knows 20% of all there is to know, because that's the physical world, I would say it'd be 20% or less would be the highest estimate that I could give reasonably, because that's the observable universe that we can actually interact with. We know about 20% of all there is to know. Wow, that's pretty low. Of that 20%, we probably don't know all about all the 20% of that. So it's much more likely that we know like less than 5% of all there is to know about this reality. And when you think of it like that, science is useful, science is good, but science isn't something you put your faith in, right? It's not something you believe in with a pseudo-religious kind of fervor. I've heard over the last few years, follow the science, and it rings with a kind of religious zealotry that is really bizarre, given that science has no idea what it doesn't know. And my suspicion is that science doesn't actually know a lot. And so when you have scientists that say the only knowledge is scientific knowledge, I cringe in my gut, because that means that we know almost nothing. Because the more science learns, or the more I've learned about science, the more I've realized there's so much we don't know. Now, is science a good way to know things? Absolutely, especially if it's done by really ethical, really transparent people who don't have human motives. And there's a few out there. I've met a few really phenomenal scientists who are actually good people, who are motivated by really altruistic motives, and they do great science. I don't want to come across as being a science basher per se, but again, this is a limitation. Science doesn't know what it doesn't know, and that's an important thought. So, examples again, dark matter and dark energy. These were the two things that really brought my mind to this notion about what science doesn't know. And that makes up the vast majority of the universe, well over 80%. I believe I've heard some estimates as far as 90% dark matter and dark energy together. And that's a huge amount of I don't know. And what other things exist like this that we just don't know anything about? And it could be a lot, you know, it could be shockingly a lot. Now, one of the things about science that should be pointed out is that it can only provide conditionally plausible explanations for things that are inferred, right? So, what does that mean? It means that, for example, the Big Bang model of the universe is what we understand happened based on the knowledge that we have. Tomorrow, there could be an advance in physics where we develop a new type of sensor and we have a new view of how the entire universe expanded and developed over time, meaning that what we think now would be shown to be completely wrong. Like Newtonian mechanics was shown to be completely wrong. It was functional, it was useful for predictions, but at the end of the day, it was still wrong and has been replaced twice over now. First by Einsteinian general relativity, and now by quantum mechanics. So it was a conditionally plausible explanation. It's plausible, meaning that it could work this way, and it seems to work this way based on the ability we're able to use it to make predictions, but it's only conditional because with new data, it could change. And again, we don't know what we don't know, so what could change is everything, really. And then sometimes science is just plain wrong. So you see these two articles from Time magazine, both based on the best science at the time, where in 1977 we were going into a global freeze. This was just before I was born in 1980. And in 2008, the global warming was going to kill us by, I think now actually 2024 as the time of this video. I think I saw at least one article in the 90s that was saying that by this time we should have mass desertification, famines, droughts, suffering, evil, horrible death, catastrophe of all kinds, just the worst things happening. So that we're still here, we're still kicking, and Florida is still not underwater. Sometimes science is wrong. It happens, right? Now, there are two types of science, and I want to clearly differentiate between these two. There's empirical and experimental science, which is done in the laboratory under controlled conditions with controlled variables. And I would actually say that empirical and experimental science is highly reliable because you can go back and you can test it and see if you get the same results. That's good, reliable science. In fact, you have to have pretty unethical individuals who are very clever to falsify science of this type. It's not saying it's not done. You can do tremendous things with p-hacking and statistical shenanigans, we will say. This is a ninth grade class. I won't go too depth into it, but you can definitely get a lot of wiggle room in this type of science too. But it's harder to cover up because you give your procedure, another scientist can go through it and say, I got nothing even remotely like what you got. So this is more reliable, but it's not 100% trustworthy. No science should be considered 100% trustworthy, right? Because it's done by humans. And humans have intellectual limitations, motivational limitations, all sorts of biases, but it's much more reliable than the other type of science. It usually is reliable, we'll say. Now, the other type of science is what I'll call inferential science. And inferential science is where you, like a forensic scientist, take the information at hand and you kind of piece together what happened. And this type of science can only give you conditionally plausible explanations, right? So earlier in a lecture, I talked about evolution being defined two ways. Because if evolution is defined as small change over time, well, that could be determined experimentally and with through direct observation. That would be a pretty reliable assumption. But you taking the fossil record and inferring that all of life came from one single cell in the extreme distant past, given the processes we see in action now, that's a conditionally plausible explanation. And it could change tomorrow based on a single new fossil find, right? That could change everything. They could find a early human civilization smack dab in the middle of the Cretaceous period, and our entire understanding of history would just go out the window, right? So it's conditionally plausible. It doesn't mean it's true, right? What actually happened in the past is in the past, and we might not actually ever know. But science, given the rules of only matter, energy, and the laws of physics, has put forth a conditionally plausible explanation of what they think happened, which is great. It's interesting. It's lovely. I have no problem with it. But it doesn't mean it's true, real, or actually ever happened, right? It's just conditionally plausible. Oh, this is the example that I just explained. Evolution you can test in real time in bacterial populations right now, but piecing together what happened in the extreme distant past, extrapolation works in some places and it really doesn't work in others. It's only conditionally plausible. Okay, so what are the limitations of science? Hopefully I've put forth a at least somewhat fair example of several to consider. And again, if you have never thought about what limits there are on science, and you've never heard about these limitations ever presented to you, you should really wonder why. Why are the limitations of science not something that are talked about in every science class? Why aren't they the default understanding? Why aren't they pointed out? What interest do people have in not telling you that science has obvious limitations? It's a fair question, and I hope you take some time to think about it. I'm not going to answer it for you. I'll let you answer it for yourself because I want you to be critical thinkers. Thanks so much for listening.